Okay, so we've looked at differential equations, solving them analytically using separable equations. We've looked at a numerical approach using Euler's, and now I want to look at a graphical approach. So these are called direction or slope fields. And basically the idea is that recall that dy dx is the slope of the tangent line. And what we can do is we can plug in the value of a certain point. So if I picked like this point here, and here x is 2 and y is 1. And so I can plug those values into whatever dy dx is and figure out what the slope is right around this area. And I can do that for every point on the grid. And this is going to give me a picture of kind of what that solution curve is looking like. So with this example, dy dx is equal to y. The way that I would plot this, since I know that the y values are going to be the same as I go across this way. Okay, so I know here y is equal to 0, so these are all going to be flat lines. Here y is equal to 1, so we gave each one of these a slope of 1. Here y is equal to 2, so a little bit steeper, and so on. And down here, this is like y is negative 3. So this is pretty steep downslope. So if you go through and you do that kind of as a grid of points across your graph, you're going to get a good idea of at least what that solution curve is going to look like, right? And so if we're looking at this, kind of what I see here is that we have some sort of exponential solution lurking in here. Okay? And so it actually turns out that if you solve this, the exact solution for this differential equation is an exponential. So hopefully that gives you a little bit of an idea. Now that you've seen one, let's actually draw one out. Okay. So I have the slope field for dy dx is equal to 2x. So know that along this line, x is equal to 0. Along this line, x is equal to 2. So what I'd like to do, since all I have to do is plug in x, I want to do all the ones along a specific line first of x values. So here x is equal to 0. 2 times 0 is 0. So these are all just going to be little flat lines. Here, this is x is equal to 1 along here. So 2 times 1 is 2. We'll give these guys a little line like this. Here, x is equal to 2. So this is going to be a little steeper because 2 times 2 is 4. So we'll sketch some of those in. Now let's look at the negative side here. So here, this line is going to be x is equal to negative 1. So 2 times negative 1 gives me a negative 2. Some of those guys in. Here, this is x is equal to negative 3. So 2 times negative 3 is negative 6. These are going to be really steep. Okay, these are a little less steep. Okay, and so what we start to see is that we have a solution field that looks like it's an awful lot of parabolas here. Okay. And it turns out this one is separable. We can certainly solve this one, and we do find that the solution is y is equal to x squared plus some sort of constant. So this process of drawing these slope fields or direction fields gives us a good idea of what we're looking at in terms of a solution.